Okay, so continuing on with z-scores. From chapter 4, we learned about something called a deviation score. And we got that by taking a raw score and subtracting from it the mean of those scores. And we said that gave us 2 bits of information. It gave us, of course, a number value, which told us how many points away from the mean that raw score was. And it gave us an indication of being positive or negative. Positive meaning that raw score was above the mean. Negative meaning that raw score was below the mean. A z-score kind of tells us the same 2 bits of information. It's going to give us a number value when we calculate it. That number value tells us not how many points away from the mean the score we're interested in is. It tells us how many standard deviations from the mean away it is. So instead of measuring distances in terms of just raw score points, we're going to say, well, how many standard deviations away is this score? So the number tells us how many standard deviations from the mean a score is. And like a deviation score, it can either be positive or negative. If it's positive, then that simply tells us that score is located above the mean. And if it's negative, it's telling us that that score is located below the mean. So very similar to a deviation score, but we're measuring in standard deviations, not in raw score points. A lot of what we're going to do through in working through this chapter is we're going to look at mathematical approaches and sort of picture graphic approaches. Some students think a little bit better in pictures, some think a little bit more in the math. And you should be able to do both. You should be able to see how they line up. If you can understand these concepts, both in terms of graphics and calculators, then you really are probably in pretty good shape. So let's start by considering our normal curve. One of the things we saw a little bit of from chapter 4 was putting our standard deviation lines in here. Standard deviations, right? So they're not in random places, they're in standard places. What we end up doing is taking this normal curve and we basically segment it. We're going to cut it into parts that are in very predictable places, like the lines on a football field, right? They're very regular intervals. So we're going to put some standard markings on the field here, if you will. So we can put one down here in the middle. Of course, that's where the mean would be, mean, median, and mode probably, if this is perfectly normal. And then we come off to the left a little bit, and we're going to put a standard deviation line there. And off to the right, a standard deviation line there. And we can continue adding. There's a second one and a third one on that side, and a second one and a third one on that side. Pardon me. Technically, that goes on for infinity, if you will. It's considered an infinite figure. So standard deviations just keep going forever. But for us, we'll rarely need to think about anything but beyond 3 standard deviations. So a big part of, if you think about back in chapter 2 when we were talking about making tables and making graphs, getting your workspace set up is a part of that process. That'll be something that you'll be doing quite a bit in this course, is to one degree of formality or another, kind of getting a workspace set up. So this is sort of a blank space to work from. So let's consider if we had got some information and did some calculations and found that our z-score was a +1. What does that tell us? Well, the positive tells us that it's located above the mean, so it's going to be on the right side of the curve. And how far above the mean? Exactly 1 standard deviation. So this would be right there at that line. If we found that we had a z-score of negative 1.75, well, where is this score located? What's its address? Well, negative, so it's on the left side, and it's exactly 1.75 standard deviations. So we'd go over 1. If we went all the way over to the next line, that'd be 2. So we just want to go over about 3/4 of the way. We're just kind of eyeballing it. So that looks to me that it'd be about there. That's all a z-score is. Positive or negative, is it above the mean or below the mean? And how far above or below, measured in standard deviation units. Now, remember, one of the things that sometimes trips students up, we talked about in chapter 4, distance has to be positive. Standard deviations are always positive. It's a measure of distance. How far from the mean is something? In this case, the positive and the negative, it's just like saying you live on the left side of the street or the right side of the street. That's all it is. It's not saying anything else by being positive or negative. It's just pointing us to which side of the curve that we should be looking at. But this isn't saying the distance is negative distance. It's just saying that it's located on the negative number side, if you will. So that's the gist of all a z-score is. Now, of course, we'll have to look at how to calculate them and use them for other things. But that's all it is. Is it above the mean or below the mean? And how far exactly as measured in standard deviations. So, let's see here. So let's keep our curve there for a minute. So let's say that we have a distribution of scores, and we happen to know that this distribution of scores has a mean, we'll call it a population for this example, a mean of 30 points, and that it has a standard deviation of 8 points. Okay, so the first thing we would want to do here, or one of the first things we should want to do, is draw a curve and plug in the information we've got. Well, that tells us that the mean is 30 and that the standard deviation is 8. So we're counting by 8. So we go up by 8 to 38, go up by another 8 to 46, go up by another 8 for that last line there to 54. And again, technically that goes forever, but we don't have to take it to extremes. Now we count by 8s, but going down. So 30 minus 8, so we go down to 22. And then minus another 8 down to 14, and then down another 8 to 6. Now these are raw scores, right? That's the raw score mean, the raw score standard deviation, and so there's our standard deviations with the raw scores. And let's say someone in this distribution got themselves, they scored a raw score of, let's say, 38 points. Now, without any calculators, without any formulas, we should be able to figure this out, right? So what the question is, what is their z-score equivalent? This raw score of 38 is the same thing as a z-score of what? It's like saying a temperature Celsius of 50 degrees is the same as a temperature Fahrenheit of what? Again, we're just transforming, we're just converting scales. Well, if we look at it, where's 38 located? Well, it's exactly right on that line. So start with, is it above the mean or below the mean? Obviously it's above the mean, it's to the right, so it's going to be a positive value. How far above the mean? It happens to be exactly 1 standard deviation above the mean. So its z-score equivalent would be positive 1. A raw score of 38 is the same thing as a z-score of positive 1. That raw score, and again, notice we haven't changed what the score is, where they're located. We're just changing the scale we're using to describe it. So what will we say about that score? It's at the top end of typical, the top end of the average range. There are other ways of defining average range, but we're using that idea. So it's at the upper end of that middle 70%. There it is. Now again, of course, the math, we'll get to where we're going to need formulas and things, but it's pretty straightforward. That's all we're doing, again, for this first purpose for z-scores. So let's continue thinking about this in the next clip, and we'll do some more examples.